Welcome to today's Explainer, folks. We're setting the stage for a massive paradigm shift in how we understand the absolute essence of programming. We're getting into the art of the function, SICP, Python, and the soul of computation. Look, if you're ready to move past just writing endless lines of code, and you genuinely want to grasp the foundational logic that powers the whole shebang, you are in the exact right place. Let's get into it.
Okay, let's dive into this. We're talking about a text that carries an almost mystical reputation in the programming world, the legendary structure and interpretation of computer programs, universally known as SICP. Sources actually describe this book as having the power of altering your fundamental beliefs about programming. Just let that sink in for a second. It doesn't just teach you new syntax, right? It literally rewires how your brain processes logic and computation from the ground up.
Section 1. The book that changes minds, exploring the legacy of SICP.
You see, SICP isn't just some dry, dusty academic textbook. It's a foundational artifact. It's renowned for completely reshaping how developers perceive their craft. It takes programming out of the realm of mere typing and elevates it to, well, a profound way of thinking. So, the crucial point is, the true soul of computation lies in functional programming and recursion. When you strip away all those flashy user interfaces and complex modern frameworks, you're left with these core, beating principles. Our sources highlight that truly grasping functional programming and recursion is the ultimate key to unlocking the raw potential of computational logic.
Section 2. The soul of computation, unlocking functional programming.
I actually want to pause right here and pose a direct question to you. What exactly is recursion? Take a quick moment to think about it. It's a term thrown around a lot in computer science, but pinning down its true essence is really what separates the novices from the absolute masters.
And this brilliantly illustrates what it is. Recursion is simply a function calling itself to solve smaller subproblems. It's this incredibly elegant process of taking massive, unwieldy issues and dividing them up into highly manageable, self-referential pieces. Think about it like this. Instead of tackling a giant mountain all at once, a recursive function takes a single step, and then calls upon an exact copy of itself to take the very next step.
Section 3. Solving problems with recursion, the engine in motion.
Think of recursive problem solving like a punchy, active engine in motion. Step 1 is the problem small. Step 2, if yes, return the answer. Step 3, if no, break it into smaller parts and call yourself again. Imagine this loop firing repeatedly, faster and faster. The function asks, is it small enough yet? No? Break it down. Call itself. Is it small enough yet? Yes. Boom. The answer cascades right back up the chain. It's an absolutely incredible way to visualize reaching a computational solution.
Section 4. Translating scheme to Python, from past to present.
So let's bring this beautiful, abstract theory back into the real world. But before we make that jump, let me hit you with another quick quiz question, just to establish our historical context. Which language is typically used for the original SICP curriculum? Any guesses? The answer is Scheme, which, if you didn't know, is a dialect of Lisp. The original magic of this foundational text was written entirely in Scheme. It's a language completely famous for its heavy use of parentheses and its incredibly elegant, minimalist approach to functional programming. Let's move to how this builds into our modern workflow. We're looking at the classic academic logic of Scheme and Lisp versus the modern, practical application of Python. What our specific resource successfully does is translate that classic Lisp logic directly into Python, the language you and I are overwhelmingly likely to use today. It essentially takes this ancient programming wisdom and applies it directly to your modern workbench, a real game changer.
Now, what's really interesting about this is the ultimate payoff. By mastering abstract problem solving, you learn to naturally divide complex issues into those manageable parts. You utilize self-referential logic loops, and you successfully bridge that classic SICP theory with modern Python. Honestly, mastering this recursive loop equips any programmer with elite problem-solving techniques, absolutely regardless of their background or what language they happen to be typing in.
So, here's the big question. Now that you know the recursive essence of logic, what complex problem will you break down next? I really want you to take this paradigm shift and apply it directly to your own programming journey. Remember, don't try to tackle the whole mountain at once. Break it down, let the function call itself, and just watch the solution elegantly unfold. Thanks for hanging out with me for this explainer, and keep on learning.